All right. Hey, it looks like we're live now. Hey, Scott.
Nice. Hey, Steve.
All right, let's get going.
All right.
Yalla.
Well, thanks everyone for coming to our presentation today. Today we're going to be talking a little bit about digital ledger technology, trends and patterns that we've seen in the space, post quantum risks, everyone's favorite topic, along with AI and how it kind of plays a role in the future, not just in crypto, but kind of everything. Today we have two speakers. The first is Steve. He is the CTO and co-founder of Halborn. And we also have Sudha from Citibank. She's the head of security architecture as well. So I'll let them both introduce themselves before we get started. So please go ahead.
Ladies first. Go ahead, Sue.
Okay. Uh, Thank you, Halborn, for having me as a part of this tall order discussion today. My name is Sudha Iyer, and I lead Citi's enterprise cybersecurity architecture, while also serving as the chief cybersecurity architect for digital assets at Citi. My team oversees standards, security frameworks, and patterns for most critical, business critical, and innovative digital initiatives. In my role, I am always ready to take point, and sometimes it's taken advantage of, but I'm ready to take point when needed and ensure that we remain proactive and resilient in this rapid evolving threat landscape. I'm passionate about adapting to new changes and continuously learning, driving cybersecurity innovation in quantum and digital asset space. This is me today and hopefully better tomorrow. Over to Steve.
Awesome. Thank you. Wow, that's a hard one to follow up with. It's great. Nice. I'm excited to talk to you. So I'm Stephen Walbroehl. I'm the co-founder and CTO for Halborn. We're a firm that specializes on emerging technologies and digital transformation for financial services. We specialize in blockchain. I've been an enthusiast in that technology as well as cybersecurity for over 20 years. And I was a Bitcoin maxi from early days on, and I've been doing cybersecurity for many institutions throughout my career. I also am the author and instructor for the former SANS class on blockchain smart contract security. Very passionate about technology and also AI as well. Researching a lot about that as we look at how to secure that new emerging space there too. This is great. I'm excited to be here and talk about all the things about DLT, cybersecurity, and AI today.
Great. Thank you both for your introductions. Obviously, we have a few questions, but I'll just make an announcement just to get started. You can put questions in the chat. We're going to be handling Q&A at the end of this presentation and discussion, so feel free to drop them there. Just to get started, before we get under the hood, get deep technical. First question, I guess, Sudha, if you want to go first here, and then Steve, there's a lot of trends, AI, whether it be quantum computing, this and that, in the digital asset space. We see the meta, we see the narratives. What are you most passionate about? What are you excited about? And how do you see things sort of changing over the next few years as we lead towards more adoption of digital assets?
Yeah, I will give a little bit of context before I answer that question. Uh, Cybersecurity architecture, right? So financial industry, financial assets industry has always relied on robust mathematical foundations to meet security. So you need robust calculations, you need robust compute in order to meet all the necessary cybersecurity or any even your business delivery requirements. In the digital realm as well, the same principles apply. Digital assets must also have credibility, provenance, and strong cryptographic protection from both hardware as well as software levels. However, technology is cyclical, which means that there is an end. It plateaus after a particular point of time, which means that the current digital hardware technology might have reached the plateau level. There is no further growth as per Moore's law as well. which means that transistors will grow smaller in size but be more like 2 times effective. That's no longer happening. It has plateaued. And so the mathematical processing capabilities are not meeting the current software processing capabilities that might be able to meet the technical advancement. So considering all of these, I would say the two trends that excites me the most are the hardware level mathematical space advancements like quantum technologies and cryptography, and the software statistical level advancements with AI. Um, Both are in early stages. However, they both, like the quantum and AI, have potential to complement each other in the financial industry, and blockchain can be the glue to bind both of them. That's my personal conviction. It's hard to predict how they will evolve because there are error corrections that are needed on both the fields. So that's what I think. What do you think, Steve?
I think I love mathematics as well. Math is one of my favorite topics as a kid all the way now. So of course, cryptography leading into that is great because I like to, solve problems and puzzles as well. But the things I'm most excited for in the space of starting with AI is really the productivity gains that we see across the board on everything right now. From just using like even IDEs and code software like Cursor, for example, just to help you like develop faster. I think we're going to see things come out a lot more rapidly, and the productivity gains, whether as a user or even myself as like founder of Halborn, my team using AI enabled technology, we're able to do a lot more things to give a lot more service delivery improvements to everybody. So I'm excited for that. And also for like with DLT, I'm really excited about the advancement of the technology to provide faster, more efficient, more reliable, and more secure, if they do it correctly, services for financial customers. So institutions like Citi and others are being able to adopt this new technology and be able to deliver tokenization of these assets and all of these like innovative new financial services in more effective ways. So I'm really excited to see things be pushed forward that way.
Great. Thank you both. This next question is for Steve. Obviously, we work on a lot of different things at Halborn regarding security. If you're following the news, many prominent compromises regarding private keys.
Yeah.
Steve, can you talk a little bit about the importance of this with regards to custody for large financials?
Yeah, when you look at digital assets custody and the need for financial institutions to look at the security for custody, what we mean by custody is the cryptographic keys. The cryptocurrency or blockchain is based on really the essence of a public-private key and being able to unlock and move the assets on chain. So holding this is pretty much you need to have this as your primary concern for all security. So it's essential there. And there's really areas that you have to look around it, not just the key theft, but you have to be concerned with just key loss as well. There's different ways and approaches to protecting this key, but also generating it and refreshing it. Whether they're using HSMs, which is a very secure method of doing that, versus something like multi-party compute, which is sharding up keys and having other people have it. There's a risk of loss as well, and not from like a bad actor, just from bad custody practices. And it's very different from normal financials where you can't just reverse the transaction by calling up a help desk and sending the wire transfer back. It's lost to mathematics forever. So it can be irreversible or immutable. So you have to consider these things, just like the CIA triad for the security professional out there: confidentiality, integrity, availability. Having the integrity is usually covered by blockchain, but the having have the custody of this, you have to look at the availability as well, so that you don't lose those keys. And then confidentiality, make sure you keep it secret so nobody can steal it.
Oh, Thanks, Steve. Yeah, I think your point about availability is well taken. Just from a security perspective, I don't know if everyone always puts that as a high priority, but it's just as important, of course.
Yeah.
Sudha, this next one is for you. I mentioned it early, but everyone's favorite topic, post-quantum threats.
Ooh.
How do you see this sort of playing in the financial industry today? Are there things that you've observed or you feel that we can do today to help get ahead of these potential risks in a post-quantum world?
Actually, I'll pick up on what Steve pointed out because it was an important topic. And to know the risks of post quantum and anything related to cryptography, we really need to look at or revisit history. Cryptography related to cybersecurity was implemented post World War II, where all the cryptography was designed to successfully mitigate the risks pertaining to human life. Earlier, it used to cost a human life if a secret or a secret key was revealed. I mean, because they were like latched on to the person, and if the person is dead, or if the secret is revealed, the person is dead, vice versa. So, in order to reduce that human danger to human life, internet and cryptography were actually implemented in a way so that the human factor or risk to human life is reduced. But at the same time, the data security is there. There is no collusion like two or three people coming together because they have the parts of the keys coming together and then kind of solving the problem. That's why you needed. That's why the standards such as NIST and then hardware security validation modules and programs and attestations, all these came into place. So these were structured ways. These are providing structured ways for key custodial actions and risks against them. So the new changes with digital assets framework brings the risk on the code side, because most of the digital asset custody designs have coupled key management on the SDK or code level, which makes it very, very difficult to find out which cryptographic algorithm was used, or how do you ascertain which key was used and all. You just assume that, okay, it's taken care of within that module. But tomorrow, if that developer leaves the organization, or if a person who was given the training did not pay attention really, it is possible that these kind of issues can be overseen, and it's really practical. That is why there is a need for that centralized custody or trained custody keeper of your keys. So fast forward in 2016-17, we observed that public key encryption can be broken with quantum hardware technologies, and this also means that you needed some solution before the quantum technologies are available to be released. So NIST thankfully has released the first three standards for post quantum, and uh, there is no need to panic. But then there is definitely the message itself was that there is no need to panic, but then people need to work towards building the infrastructure based on these cryptographic algorithms for the next 3 to 5 years. Obviously, like we pointed out earlier, the solutions are not ready. Uh, there is still a lot of error in these technologies. So it's not yet ready, but then we need to prepare. We need to know where are the keys so that you can flip it to the post quantum resistant keys. You need to have a complete idea of governance from generation, rotation, all the different aspects, usage. Currently only usage has been taken care of. It you should also look at the other aspects. So uh, these are the immediate things that business could start planning and incorporating in their post quantum resistance infrastructure and security strategies. What do
Also,
you think,
one thing,
Steve?
yeah, one thing that's interesting about that, Sudha, is we always think about quantum, and then we immediately start to think about its effects or risks on like cryptocurrency or digital assets. And the truth is, I think that we should look at it broader, because these algorithms that are being used for cryptography is not just for digital assets. Like, we use this for TLS and SSL as well. Public key algorithms work the same way as they do on the blockchain as they do for the normal internet. So if quantum computing is a risk, for whatever reason around the computational power, which we can argue that probably all day long with about if it is or not. The thing is, though, it's a risk for all of the cryptography. The normal internet as we use it today will be impacted as well, not just digital assets. So it's much broader than just that. I don't think we should look at the myopic view of just saying digital assets are a risk, because it's there. And your point around Sudha, I really like discussing things with Moore's law about hitting that limit of like the transistors being able to process this. It's very interesting too, because hash power is needed, using quantum computing and qubits to break it. And there's Moore's law, and there's also like Grover's algorithms and Shor's algorithm. These are ones that are very can make it stronger to have a computer do it, but there's a high cost for that, and there's a ceiling of limit of computational power one is going to invest in order to crack it or break it. But mathematics really has no ceiling. It can scale infinitely, and the cryptography can go from multivariate cryptography. You can do lattice-based cryptography and keep on moving higher and higher as make it more resistant to to breaking. So I think that's there's a different type of race that we have there. So just wanted to think that one of the takeaways, it's not just about digital assets, like quantum cryptography.
Correct. So it's about changing the technology. They will no longer use transistors. They would use something like atoms and electrons to measure the states, and then these are also in a controlled state, so they have to keep, there are only a handful of bits that they are that is available even in the labs, or in something that IBM and Google and the other US bodies have started to create. There are also Chinese like innovations that are happening in this field, but it's only handful. And breaking something like say 1024 bit algorithm means you need over 1 million bits, qubits, I mean, to work on this to get an accurate result. And still, there is also, even with the handful ones, there is a error rate of like 20%. That is not acceptable. So in any engineering, it is expected to fail at the start. So all the technology that we have as of date has error corrections. The cryptography that we have has gone through error corrections, and then it has been fixed over time. The electric bulb is also like this much volt, this much filament. I mean, everything goes through that error corrections. But as of now, quantum has not met that requirement. It's not efficiently providing one specific output. So that is the thing.
It's very using like the electrons of an atom, like moving as waves, not like as particles or like bits, like 0 and 1. It's just like, where is it in the within the atom to view the probability of a certain area. It's like a different model that's it works completely different.
Yeah, it's like multiple bits are controlled with, so it's like continuously moving electrons, like it's completely moving, right? So you have to reduce the temperature in sub-zero degrees so that you can reduce the movement of the bits, so you control the movement of the qubits, and then you introduce changes to the state based on ripples, like features that are there, and then measure the state changes over there. There are interesting new network topologies which are also coming in, like Petri nets, which could complement this. But quantum is a hardware-based machine learning opportunity, wherein multiple states are it's like a camera, right? If you're this camera is only looking at me in one angle, so this is a 0 or a 1 setup that we have in the digital age. If there were different cameras for the 3D what you say, the VR view, that's what quantum is going to do. So it doesn't mean that my state is changing. My state is the same, but it's just that it is measured in different variants. That is what quantum is doing. So if that machine is capable of bringing that capability, then you obviously cryptography can be broken because it will be treated in that multi-exponential dimension. But it also brings so much of opportunity. Like you could see that there is no processing time. You'll have a very fast processing time, so your transaction processing queues will be faster. Your reconciliations will not be required probably if you're using DLT and quantum. So I'm really excited about this.
Yes, that's awesome. And I wonder, like, the hardware costs for running this too, to be commercialized and adapted by businesses, in general for it, because it's like Schrodinger's theory, where you have like the natural consequence from the wave equations. So, but yeah, we can go into the super technical. I'm sure maybe some people's eyes are glazing, like, what are these geeks talking about right now?
Yeah, it just became a
Yeah,
talk between you and me.
yeah. Yeah, Scott, back to you.
Yeah, no, good discussion. Really interesting just talking about the different state, where something is, probabilistic interpretation and all of that. Kind of somewhat related, but not completely, but probably in the future. Obviously, AI has become more efficient, more powerful. We've all seen it in the last few years. I guess, Sudha, how do you view sort of the convergence of AI and blockchain for a financial institution such as Citi?
Yeah, I mean, we are already using AI, not the Gen AI, but AI and machine learning for just in this context of digital ledgers, I'll speak. We are also using in other areas, but then they are always used for passive information analysis. So you already have the data, so you do the passive information analysis so that you can improve, say, on-chain intelligence. You can see what whitelisted addresses or finding out suspicious activities or fraud. So these are already being used across Citi in different businesses as well, not just digital assets. Uh, Come 2025 and beyond, I think the supervised and trained Gen AI and large language models can definitely generate or regenerate code, documentation, static code analysis, vulnerability validation for open source blockchain code. Because tools like GitHub Copilot, Microsoft Copilot, so many Copilots are there. So they can definitely build or flag non-standard code by cross-referencing your hefty architecture cybersecurity documentation. So that is going to be something that would be helpful for the technologists and as well as cybersecurity architects, because we and cybersecurity champions, because then everybody is aligned to the standards. Open source contributors currently are just dumping the code sometimes. But what would happen is if GitHub takes ownership on these kind of things, then prospectively the open source development itself would be cleaner. So when you're downloading the code, it would be a better standard code as for me. So really looking forward to the next 3 to 5 years on how these Copilot and other tools can benefit. There are different other solutions that can happen, but then there will always be that error because it's the data set. All these machine learning and AI are relevant, are dependent on the data sets that needs accuracy and are not tampered to show the metrics. We have always struggled with the metrics or metrics fatigue, wherein sometimes the metrics are projected metrics and might not be accurate metrics. And the same problem will prevail if your data sets are also, manipulated in a way so that the outcomes are different. So there are pros and cons, but I would like to keep myself positive that there's a good thing ahead. What do you think,
I think,
Steve?
yeah, no, I think they could be unified together to build on each other's really the good benefits that you can get from each. I like the example of Copilot and GitHub about code being put in there, because one is about like tainting data or tainting training data to start to throw it off, or if you have a lot of bad code out there and is referencing that too. Well, if you use blockchain or DLT, you can do incentivization for good code on there. There's been some projects out there that have done, I think it's like NuGet, and there's other ones that have allowed people that have good code, clean code, then they're rewarded. It's kind of like proof of code in a way. So you can combine that and make use the AI and the DLT benefits work together. But from a business standpoint, using there's really two types of ways of looking at it. I think the LLMs, a lot of the customer or consumer facing aspects of that is around the generative AI, being able to provide answers easier and save costs on some of that human capital that usually it has to do it, that can be a bit slower and more ineffective. And then there is the machine learning part, which is in the back end, the data analytics, and be able to solve problems for advanced intelligence faster using that data. So those two things are all about speed, quality of response, and I think that blockchain is generally looked at as, okay, well, maybe it can be slower sometimes, high TPS rates, but if I trust it, it makes it immutable. There's like a risk factor for it. So you can use AI to kind of supplement that risk factor of trust to do machine learning analytics, and then use the blockchain for the immutability and transparency aspect of that too. So kind of bring the two worlds together in the best, using their strengths.
Yeah, and I agree, because blockchain technology and DLT were built on security by design principles, improving security and assurance and provenance, whereas the other solutions were, like I said earlier, they are just hardware and software computation or mathematical platforms. So you can definitely complement quantum in different areas, like smart contracts and just the provenance part of it, saying that these particular quantum devices have these kind of assurance. And so
Right.
how the quantum is built up could be complemented by blockchain. The same thing with AI as well, to improve assurance and attestation, which is lagging over there.
That's right.
Blockchain becomes your fundamental
Yeah, a
glue
big
or
thing.
the layer.
Yeah, user behavior analytics was a big thing for maybe 5 years ago. It was the big buzzword, and now it's like you could do machine behavior analytics and stuff with all this instead.
No, super interesting. I think good points made by both of you. I'm really enjoying the discussion. I hope everyone attending is. We want to kind of leave some time for the Q&A at the end. So we're going to have our final question now. This one's to you, Steve. Obviously, I've been here at Halborn. I've seen the types of work that we do, whether it be for financials or other organizations. From your perspective, having co-founded the company 5 years now, what advice, what security takeaways would you give for organizations that are implementing digital ledger technology, custody solutions, and things like that?
So I would first, take a holistic kind of end-to-end security by design. It's a great word that you mentioned is about it, where you have to look at the whole system from an approach of the technology strategy and mitigating the risk, the operational or process strategy, and then the personnel or people strategy for that, and really take the whole system into account for it when you look at custody, not just the one custody system by itself and then that's it, because it has to integrate, it has to work for people or services, and it has to also follow a process to be scalable and repeatable to add value. So you have to look at a technology strategy to consider permission versus public. What are the benefits for my business or your use case? And look at the platforms that you're going to be building it on. For operational process strategy, are you going to do with HSM versus MPC, and the reasons why, for different cost savings or security strength savings? And then the personnel strategy, are you going to do qualified custodians and have it held externally because you don't want to have the liability or risk, or are you going to do self-custody for it, and what are you going to custody? So you have to really look at the business consideration as along with it. So it's really taking a holistic approach, doing security by design, thinking about it earlier in the life cycle as you plan and then build, develop, and then deploy, and then operate for continued. So you can't only look at it in a vacuum or in a certain silo. So it involves collaboration. It involves work with other teams in your departments and with the customers to make sure everything you're doing, is it actually adding value, or are you just making things much more difficult for your users?
Cool, great, thanks. We do have a few questions that come in. I'm just read this first one out. We're seeing governments that are migrating part of their financial systems towards maybe creating their own blockchains. When we talk about BRICS, just kind of aiming for being independent from having to use the traditional SWIFT system. I guess, Steve or Sudha, have you seen any sort of movement in this direction? What do you expect potentially to happen if large nations go forward with developing their own solutions?
I can take this one too, because I do see it. I think everybody in the world, if you're looking at BRICS versus maybe like NATO type countries, are looking at using DLT. But when you consider SWIFT, SWIFT is, I believe it's stands for Society Worldwide Interbank Financial Telecommunications. So it's just a communication framework that has a standard agreed upon message network to do settlements from I guess from large international payments between countries. So it's not about, they're building something new to be out. It's will it have adoption? Will it have resiliency? And will people use it? And people or countries will only use it if it's solving a problem or improving the situation here. So I think that the SWIFT system has been used because it's adopted and it's reached that scale that is providing value, and it's the agreed upon standard for that. Now, somebody using something outside of SWIFT for that, it's going to open up new avenues of risk. Even if they do build it and adopt it, you can have cyber warfare on that system, to find vulnerabilities and exploit it. Is it permissioned or not? Permissionless. I mean, I think even the SWIFT system right now is kind of permissioned in a way. So it's not that everybody can be invited to do this here. It's actually a bit more centralized. So if it's a permission chain, is what I see with a lot of the BRICS, building this tokenized assets, gold assets and stuff. It's all oil-based tokens, like whatever they come up with for that. It's all about the adoption of it, the resiliency of it, and will it scale to be able to be used internationally by all of the countries here. So I think we're a long way off from being able to have that strategy. It's not going to be a cutoff and then the new system. It's going to be a slow growth or slow growth to something breaking and not using. So we'll have to see where that goes right now. But it's all about adoption and solving a problem for it. So yeah, that's what I have to say about that.
Great.
Yeah, and just to add on to what Steve said, there could be a noble cause of removing corruption in some countries, like removing corruption or enabling digitization itself, like fast tracking it. So that could be one of the reasons why the governments are trying to do this at a massive level. It might not be for commercialization. So just understanding how these systems are, the purpose, like Stephen already pointed out, the purpose is important, and the coverage, what it would cover, as well as how much of adoption would be there. towards it. I, I don't think it's going to be a big issue.
Yeah, yeah. I mean, there's the Swift system here is, it could be cross-border payments for that, but there is a standard there between SwiftNet, and there are actually blockchains and DLTs that are being built to be Swift supported, but be able to act faster. Like Stellar WorldPay system is compatible with the Swift message code, and there's really different there's different messaging services underlying SwiftNet, like FIN or FIN, like the store and forward mode, and interact, file act, web access. So sending a message in the Swift format for using that framework and data standards, can adapt to DLT systems quite easily, and it already has beginning to. It's just moving a mountain when you have something so big and so widely used, to get everybody to kind of upgrade and get into like the improved version of it for faster payments, faster settlements, and the key challenges with all of that. It's not something that's easy to do. I mean, God, we can hardly even patch our Windows systems consistently here inside of our networks right now. So I wonder how we're going to upgrade like our Swift financial systems to DLT.
Yeah, I think Swift is also parallelly trying several things in terms of adoption for DLT. Like way back in 2016, they had started an initiative. Swift is also extremely large. So they are, I think, trying to cover whatever reconciliation blocks they had with DLT. So it's not going to change like just turn off this and then start. It would always be that parallel implementation.
Mm-hmm. Yeah, and there's already other like payment rails systems out there right now, so it's not like a threat. There's EFT, SEPA, BECS, they all exist right now too. So this could be just another one. It's just like again like just all about adoption scale, and the trade and settlement between it is what do people trust, and really it's the underlying assets underneath the system, I think, is more important. The U.S. dollar, the euro versus the yen. What is the actual native asset, I guess you could say, that is on the network. That's what's more important, and the trust in that. The rest is just a system to facilitate that asset.
Yeah, I think these are all valid points. I agree with Sudha, your point about there's always going to be a need for legacy systems as people migrate. We see it consistently, like in traditional, IT in general. We have one more comment or question here, just with regards to consensus mechanisms in digital ledger technology. You have an opinion on what that looks like, solving for potential inefficiencies that exist today in a post-quantum world with the use of potentially AI?
Okay, I'll take that question. So, AI and generative AI or different machine learning, because they are software based, can definitely complement quantum computing in different levels, like right from compiling to different levels. Uh, but this is all pure hypothesis, okay? uh, and again, hardware based, like I said, the multitude of variables that can capture the states of your consensus, like your traditional issues wherein there is that failure of creation of the accurate chain, and instead it just creates a different forked chain, like a parent or child. I think all those issues might get resolved. It's still a hypothesis. So because there are so many other parameters that are checked, so the block and the the legitimacy of that person and maybe their KYC, everything is done simultaneously so that the accuracy is maintained and the proper chain is resolved. Uh, so that's my hypothesis, but we are yet to see how much of the quantum availability, that quantum technology will be available. looking forward to that solution when it happens.
Yep, my take, to answer that question about the consensus inefficiency. So, taking a step back and looking at like consensus mechanisms as a definition, the purpose of it is to bring the network into agreement on a single data set or a state that exists across all of it. So that purpose here is then used for different reasons. If it's a private chain, then you don't need to worry about incentivization as much as you do like a public chain, to have people participate. So something like proof of work or proof of stake that we see like on Ethereum or Bitcoin, one versus the other, incentivization matters a lot because proof of work, if you're balancing the electric cost to how much you earn for being mining, and mining will help you earn, which is then also securing network. Proof of stake is you're locking your stake and capital there. So there's an incentivization method that you have to have for that to work. On a private chain or permission chain, it's not really about like, am I going to earn rewards on there? It's can I transact better with other participants of that? So you can look at the other types of consensus mechanisms, like a proof of authority, or even like a delegated proof of stake, or so there, these different things are all depends on like the purpose of what your chain is for, and as long as it solves that the state problem of being trusted in agreement, the Byzantine fault tolerance component of that. So really, that's you have to, in what environment are you discussing efficiencies? Is it efficient is incentivization, or is it efficient state of the network? So that's challenge that question there for that.
Yeah, and I think it could also be a different paradigm wherein you have multiple states. So currently, we only have a single state machine model. So I agree with you, Steve, on that. But because there are different states, it's like smaller petri dishes, right? You have so many different. I mean,
Relay
that's the
chain.
association. Yeah, that's the natural association that comes with quantum. You have different samples of data which are like smart contracts or different logic which is executing, and then you take a range which is acceptable. You then have to alter what is your acceptable range and what is your failure range. That helps you decide. So you have to think like nature, mother nature, how things are working, to think how the quantum state would function in the future. And again, it's all hypotheses. It would not be like, okay, from now on use this. It's not going to happen. It would still
Right.
have like
Yeah.
multiple
There's no one size fits everybody for it. There's going to be multiple.
correct. So gradually starting to change will help us adapt and adopt to
Yeah.
the next phase, which might come.
Yeah, that's actually a good point that you made about the microstates, because we've seen in the public chain stuff like Polkadot or Tendermint, IBC Cosmos. Like you have relay chains and parachains and Polkadot, and they're ecosystems within the whole chain state that have their own set of rules, and then you have these application based chains like for Cosmos. So it is like nature. You have like different organisms that are kind of balanced together in an ecosystem. And the whole biome of it is like the network for it, and the way that they interact with each other is quite interesting for it. So it's organically happening.
Yeah, and I think there is an opportunity for the risk reducers like legal and the risk team to start bringing their feedback into this kind of, so they also have a say in it, okay, you take this part of data and then work on it kind of thing. You can also tap into the states and look
Yeah,
into different aspects of this design rather than building siloed. It's considering probably as many factors as possible into it.
that's right. Yeah, we need more people to be working together to come up with the agreed upon standards frameworks, rather than independently kind of doing the same thing separately. If we can there it's like the protocol wars, I guess is what they call it in the crypto side of it. I do feel that there's going to be many different acceptable standards and different not just like one chain fits all. It's different uses for different things here. So I'm excited to see it evolves. But one thing's for sure is that cybersecurity and advisory will always be part of that to help.
Yay!
There'll always be risk with new technology, that's for sure.
Well, thank you both. Thank you everyone for coming to this today. Just 2 items to wrap up. We can share a link if you're interested in Halborn's top 100 DeFi hacks. We've taken a look just across, not just on-chain, but off-chain related as well. Good data in there. Interesting just to get the overview of what we've observed since we do a lot of security work. And then the last point here is Halborn actually has a waitlist open for our new offering that we're working on, which is Halborn Academy. If you're specifically looking for training in the blockchain space, if you're interested in signing up for the waitlist, please click the link and drop it there. And then final point before we wrap up, a feedback email. We'd love to know what you guys thought of this talk today. Any talks you might want to hear about in the future or any other events. But again, thank you guys. Thank you, Sudha. Thank you, Steve.
Thank you, guys.
Great discussion.
Great talking with you guys. Thank you, Sudha, Scott. Great job. Look forward to it.
Thank you. Bye-bye.
For myself. Thank you.
All right. Check.